Hello everyone. In this video, we're going to be solving a problem from Putnam Math Competition, which is a competition for undergraduate students in the United States. So we're given an equation that is true for all values of x that are real and for all positive integers. Sorry, I kind of typoed a little bit here, so I had to fix it. This problem is from 2010, not 2016. So we're given an equation, an identity that's true for all real values of x and for all positive integer values of n, which is f prime of x is equal to f of x plus n minus f of x divided by n. The reason why I chose this problem is because it's pretty easy and manageable. One of those easy problems on the test. Most problems on Putnam are actually pretty complicated. Now, let's go ahead and see how we can find, and of course, our goal is to solve for f of x. That's what we're going to try to do. Let's go ahead and replace n with 2 first. Since n is a positive integer, we have the freedom to choose whatever we like. Obviously, you wouldn't choose 1 million or even 4, 5, 6, 7 large values because that's going to give you something messy. N equals 2 works well, and you'll see in a little bit why that's the case. If you replace n with 2, what happens on both sides? F prime of x is unchanged, and then on the right-hand side, you get f of x plus 2 minus f of x divided by 2, which is interesting, right? This should remind you the limit as n approaches or h approaches 0 of f of x plus h minus something something, and isn't that a definition for the derivative, right? But it's not given in a limit form. You strictly have an equation, do not try limits. Maybe there's a way to solve it using limits, who knows, and you're going to let me know if you do, but this is purely algebraic, okay? So, what does this equation give us, right? Let's go ahead and cross multiply. So that gives us 2f prime of x equals f of x plus 2 minus f of x. Great. Now here's a little bit of manipulation. And to understand why we are going to use this manipulation, let me go ahead and replace n with 1 so you can kind of see what we're looking at, right? If you replace n with 1, it's even simpler. You're going to get something like f of x plus 1 minus f of x divided by 1, but we don't need to write it. So f prime is just going to be the difference between f of x plus 1 and f of x. This is a beautiful equation, something that we are going to use. Now, back to this. How do we use this information along with this one, right? So we're going to use a well-known trick that we often use with proofs of limits in calculus, in real analysis, so on and so forth. And that is taking this equation and kind of breaking it down like this. F of x plus 2 minus f of x. Now, what is the problem here? First, identify the issue. The difference between the inputs is 2. You don't want that. You want them to be consecutive like this. So we're going to do the following. We're going to write this as f of x plus 2 minus f of x plus 1 so that these two inputs are back to back. But of course, you can't just subtract f of x plus 1. You also have to add it, which is good. That works well. It's icing on the cake. Now take a look at this expression and ponder a little bit. Look at that. These two pieces are beautiful. That's what we have been looking for. And best of all, this difference is equal to what? F prime of x from here. Take a look at that. So here's what we're going to do. We're going to write 2f prime equals this, which is f of x plus 2 minus f of x plus 1 plus f prime. Because as you know, with n equals 1, we get f of x plus 1 minus f of x equals f prime. Make sense? I hope it does. Now, we're going to go ahead and subtract f prime from both sides, because why not, right? Let's do it. That gives us f prime is equal to f of x plus 2 minus f of x plus 1. Now, at this point, you could pause and actually continue in two different ways. One way is, remember, f prime, earlier we said that it's the same as f of x plus 1 minus f of x, so you could bring that down and say that, okay, this expression is equal to that expression. And what is that supposed to mean? Something to think about, right? Consecutive numbers will give you the same output difference. I don't know, something like that. But there's actually a better way to approach this problem, in my opinion. But here's what you can do. You could probably assume that, okay, if this is equal to, if this is equal to something like, I don't know why that eraser came up. If this difference is equal to like a constant, am I saying this is a constant? Well, here's the thing. When you replace x with x plus 1, you get the same thing. So that kind of tells me that this is a general expression. In order for these, okay, here's what I'm talking about. In order for these two things to be equal for different inputs, that difference needs to be a constant. Because if it's a variable, it's going to vary. For example, if this difference is equal to x, let's just say, then this is going to be x plus 1 because you're replacing x with x plus 1. Does that make sense? And their difference, and they're not going to be equal in that case. The only way they can be equal is when that's a constant. But what is that supposed to mean? That's something to think about, right? Anyways, I'm going to leave it at that because I want to talk about a slightly different approach for this problem, okay? So let's go ahead and look at it from a slightly different angle. Hopefully you're going to like it, but you could also continue this way, but I'm not exactly sure if this is the best way to do it. Okay, now, so far we got the following. F prime is equal to f of x plus 2 minus f of x plus 1, right? Now, what is that supposed to mean? Well, if you go back to the way we did this is f prime, right? And if you replace that with f prime, again, you're going to get the same thing. F prime is going to equal f of x plus 1 minus f of x. I guess we could take it from here, I guess, right? Anyways, so let's go ahead and do this. So let's start with this equation and then replace x with x plus 1 on both sides. That gives us f prime of x plus 1 equals, now be careful because I'm replacing x with x plus 1, so that gives me f of x plus 2 minus f of x plus 1. You see, I'm changing the left-hand side, and of course the right-hand side changes, but it actually doesn't because it's the same as f prime. Does that make sense? So now this expression is the same as f prime. So now we got this equality, which is critical here. So the conclusion is f prime of x plus 1 equals f prime of x. And this is just beautiful. You know why? Because we're about to do this. Let's subtract f prime from both sides. That's going to give us 0. Now we're going to define a function. This is, again, a common technique. Let's set g of x equal to f of x plus 1 minus f of x. Since both of these are functions of x, the difference is also going to be a function of x, right? And here's the cool part. Differentiate both sides. G prime, by definition, is going to be f prime of x plus 1 minus f prime of x. As you know, that is equal to 0. So g prime of x is 0 for all values of x. What is that supposed to mean? That means g is a constant. So can I just write it as maybe mx plus b? Absolutely. But that's not the goal. We're solving for f. How do you find f if you do know g? Well, here's what you can do. You can just go back to the definition. Remember, g is f of x plus 1 minus f of x. And by one of these equations again, from, let's say, here, that difference is equal to f prime, and also it's equal to the constant, right? Or, I don't know, however you want to look at it, but if this is equal to m, from here f prime becomes m. I'm sorry, by the way, this is not correct. G is supposed to be a constant, and therefore f of x is just going to be mx plus b from here. So I made it very, very confusing. So let me back up a little bit. So let's take it from here. So we define g to be the difference between f of x plus 1 and f of x. And then we differentiate both sides, which gives us 0 because this is 0. It's already known. And then this means g prime is equal to 0, which means g is a constant like m, right? And g was defined to be f of x plus 1 minus f of x, which was at the same time f prime. So f prime is constant, which means f can be written as mx plus b, which makes it a linear function. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time in another video. Until then, be safe, take care. Don't forget to check out aplusbi, and bye-bye.